Okay, so you're going to build this form here. Of course, it's not the most interesting form, and just clicking on the buttons you don't really understand what's going on here or what's the point of this, but we will build this form, and the code will be in the form like this. Now when you do your homework, you're going to create a method here, and I'd like you to use the special commenting that's available called XML formatting, or sorry, XML commenting. So remember that you just hit the apostrophe 3 times and you'll get this. So put that in there and put some comments about your method, because you're going to be building a method. So let's look at what we're going to do. We're going to have a button here, and in the button click handler, you're going to put this right here and then the end sub. Now this is the method that you're going to write, and but notice you haven't written it yet, so you're calling a method that doesn't exist yet. But that's okay, because you're going to give the definition of this method right here, and that's common in programming. You can call a method as long as it's written somewhere in your code, because the compiler will find it when it compiles the program, and it will provide links between this and the compiled and the method definition, so it will be able to find it. Okay, so let's look at the definition. So we have private, and then we have sub, meaning sub procedure, and or subroutine, and say hello, and then a comment, and then all it does is do this. It just gives a message box. So it's a very simple method, but it's good practice. It's a good exercise. So when you've completed that, save your project by clicking the Save All button on the toolbar, and run the project, and it should work. So what you've got then when it works is you've built a method, and then you've called the method. Now this method doesn't take any parameters, right? If we go back and check it, there's no parameters in here, and there's no parameters here. So it's a simple method, but you've built one and you've called it. This means this is building it, and calling it is here. So his comments are, as you know, when you double click a button or button control in the designer view, a new method is automatically created. What he means is that this is created, and we see this when we double click it. The handles over here, button 1.click statement at the end, tells Visual Basic 2010 that this method should automatically be called when the click event on that button is fired. As part of this, Visual Basic 2010 provides 2 parameters which you don't have to worry about. Remember, we talked about these a little bit. Sender and E are 2 parameters which you don't have to worry about for now. Outside of this method, or after this method, we've defined a new method here, right? The new method is called say hello. Anything that appears between the sub and the end sub keywords is part of the method, and when that method is called, the code is executed. So this code is executed. In this case, you've asked it to display a message box. So you know that when the button is clicked, Visual Basic 2010 will call the button click method. So when the button is clicked, that's an indication to Visual Basic 2010 to call this button click method, this method here. Okay, you then call the say hello method, because when this is called, then this is called. So you then call the say hello method. The upshot of all of this is that when the button is clicked, the message box is displayed, because this displays the message box. Okay, so that's an example. Now he says maybe it's not so obvious why you needed to do it this way. Why didn't you just put in a message box instead of writing a method? Well, it's not really necessary in this case, but we are going to reuse this method again for the next button as well. So maybe that's an argument for why it was worthwhile to create a separate method for doing this. Okay, so what are we going to do next? If your project is still running, stop it, return to the Forms Designer, double-click the second button, and add the following bold code to the new event handler. So when you double-click the second button, you'll create the new button click handler, which begins like this. And all you're going to do in that method, in that button click handler, is write this. So you're just going to reuse the say hello method again. Okay, and then next you're going to double click the third button, and you're going to reuse it again. Okay, so the idea is that you create a method, you can use it multiple times. It says now run the project. You'll notice that when you click each of the buttons, they all bring up the same message box. Okay. Furthermore, he makes the following argument about why it's good to do this. He says what's really important, he even calls it clever, I wouldn't call it clever, is that when you change the way say hello works, so suppose we change the say hello method, maybe we're going to make it say something different, the effect you see on each button is the same. This is really important, a really important programming concept. You can centralize code in your application so that when you change it in one place, the effect is felt throughout the application, enabling you to avoid entering the same or very similar code repeatedly. Okay, so if you change the definition of say hello, then all three buttons will have a different result, right? Okay, so let's continue. Now, as I said, the last say hello method didn't take any inputs, right? It was a very simple method. So now we want to try to build a method that does take some inputs. And we're also going to build a method that returns a value. Now this gets to the point I made in an earlier video, that what's exactly the difference between returning a value and showing a message on the screen, because our say hello method returned a message to the screen, or gave a message on the screen, right? It said hello, right? So that's kind of returning a value, but we don't really call that returning a value. So in the next example, we're going to do something that we actually call returning a value. So in this next example, we're going to build a function which, one, takes an input, which the previous method didn't, and also so-called returns a value. So let's see what that's about. So he says you'll build a method that can return the area of a circle if its radius is provided. So we provide the radius to our method as an input to the method, and then it's supposed to give us the area of the circle. And as we said earlier, of course you take the radius and you square it, and then you multiply by pi. So now we're going to go back to the same form, and we're going to add some new code. We're going to add this code here. So we're going to add something called private function. Calculate area from radius is going to be the name of this function, or the name of this method. And we're going to add in this code. So let's take a look at this. So what are we going to add here? You have to write that it's going to take an input which we're going to call radius. So we're going to refer to the input as radius in here. So whatever the user puts in, we will perform different things on radius, and we'll refer to what the user's putting in by the word radius in our code definition. Okay, so anyway, you have to type this. Then what's the first thing we do within the method? We declare a variable within the method. Now we haven't done that before. We haven't declared a method, variable within a method, at least not in the last example. And here we declare a second one. So what's the first one? It's a double, and it's called double radius squared. And we have another one called double result as double. Okay, then remember that what the user puts in is going to be considered to be the radius for us. So we're going to take what the user puts in and do what to it? Square it and assign that to double radius squared. Okay, so basically this will be the radius squared. And then we're going to take this and we're going to do what? We're going to take it and we're going to multiply it by times math.pi. Math.pi is a way of accessing the value of pi, the number pi. So we write math.pi times this, which is the radius squared, and we're going to assign that to this. So that's going to be the square of the radius times pi. In other words, that's going to be the area. Okay, now we want this is, as we said, we're going to have an output. So the output should be this. This is what we want to output. We want to output the area. This represents the area. And so to output that, we put this statement here. And you'll see what I mean by output it in a minute. But anyway, to output it, we use the return statement, means return to the user this, which is the area. And then we write end function. So you should type this in, and then we're gonna. But this is just the definition of the method, or the function in this case, but the method. And but we haven't actually used it. We've created the function, but we haven't used it. In other words, we haven't called it yet. So we want to call it also. So we're going to call it in the first button. So he changed, where is it, button 1. He changed it to this. So how is this changed? First of all, he created a variable, a double, called double area. Okay, but that's just the declaring the variable. Okay, now what was the name of the function that we just created? Let me go back down. What was the name of this function? Here. Calculate area from radius. So that's the name of the function. And how many inputs does it take? 1. Okay, so now what's he do here? Up here? So we just said we create this variable. And then what's this? He's calling the function that we just created. Now this function does take an input, right? So we need to give it an input. So he's giving it an input here. He's giving it the input of 100. In other words, the radius is 100. And so what's it going to return? Remember we talked about it returns something. So what's it going to return? It's going to return this, which was the area, the calculation for the area. So it's going to return the area. So when we put in 100 into the function, we say what's going to be returned by this function is the area, and that's going to be assigned to this variable. So the return is what you can then set equal to something else. Okay, so now we have the area in this variable, and then what does he do? He just displays that, and he says it's the area of 100. Okay? So type this, and both parts, you have to define the variable, you have to define the function or the method here. Okay? And then you want to call it, you need to do all of this. Okay, so do that. And also he says you have to delete the existing code from the button one click event handler, of course. And when you run it, you'll see this. So finish that up, and then when you're ready, we're going to come back and we're going to read the detailed discussion of what we've done, because it's very important. So pause it and come back. Okay, so let's go through this. This is very important. In this exercise, you build a separate method called calculate area from radius. You do this by using the private function end function block here. So it's private function, then the name, parenthesis, then this thing Byval, radius, Byval means by value, as double, radius is going to be a data type of double, and then as double, and then we're going to put stuff in here inside, and then end function. Okay, so let's try and understand what these different parts are about. Anything between the function and end function is the body of the method and will be executed only when the method is called. Okay, the Byval radius as double. The Byval radius as double portion defines a parameter for the method. The parameter's name is radius. When a parameter is passed by value, as indicated by the keyword Byval, .NET in effect creates a new variable and stores the past parameter information in it. So what does that mean? Well, what did we put into the method? Do you remember? Let's check it. We put this number 100 into the method, right? But we might have, instead of putting 100 in, we might have put in some variable that was maybe equal to 100. Maybe we had some variable, we called it x, and x maybe we set it equal to 100. So instead of putting in 100, we could have put in x in here. Okay? And further, maybe inside the calculate area from radius method, maybe we reassign x to some other value. Maybe we say x equals x plus 100. We wouldn't do that in this case, but maybe in some other case we would. We reassign x another value inside the definition of this function. The question would be, what happens to the x outside of the function? Does it get changed or not? So inside the function, let me see if I could write this. So inside the function we might write something like this, inside the function definition. But remember outside the function, outside the function I said maybe we created a variable and we said let it equal 100. Then inside the function we do a bunch of things inside the function definition. And one of the things we do is this. Okay? The question is, let's see. The question is, so the new value inside the function will be 101, right? Does that change the value of x out here or not? That's the question. This is a question of what's called scope, which we're going to talk about later, but it's coming up here. So going back to this, the Byval radius as double portion defines a parameter for the method. When a parameter is passed by value, as indicated by the keyword Byval, .NET in effect creates a new variable and stores the past parameter information in it. So what it's saying is it creates a new variable inside the definition of the function, so that whatever happens to that inside the function doesn't affect what's happening outside. So my question was, does this value get changed to 101? The answer is no, because we defined it in this way called Byval. Okay, so that's the point of Byval. This will change to 101 inside the function, but this won't. So if you want that to happen, you have to, if you don't want, the variable where it exists elsewhere in the program to change, you have to, when you define the function, you have to use the Byval keyword. So he says, even if the method is called with a variable given for the parameters, that's what I said, we put in x instead of putting in 100, the contents of the original variable are not modified by the method. In this case, you're telling .NET that you want to pass a parameter into the method called radius. In effect, this statement creates a variable called radius, just as if you had done this, dim radius as double. So what he's saying is, this part here creates a variable called radius. He stopped talking about Byval. In fact, there's a little more. The variable is automatically set to the value passed as a parameter. So what he means is that when you call the function, if you put in 100, then that variable, this variable, gets the value of 100. If you put in 200, this variable gets the value of 200. He says, so if you pass 200 through as the value of the parameter when you call the function, you're effectively doing this. You're now assigning the radius to equal 200. He says if you passed it this number, then it would be doing this. It would be assigning 999. Now he explains another way of passing a parameter is by reference, that is, using this keyword instead of this keyword. When a parameter is passed by reference, the parameter name used within the method body effectively becomes another name for the variable specified when the method is called. So anything the method does that modifies the parameter value modifies the original value as well. So in that case, if we had defined it by reference, then when we do this inside the function, this would also change to 101 outside the function. So that's the difference between Byval and by ref, or by value and by reference. Next he says, the as double sitting at the end, here at the end, not this as double, we do have that one as well, but this one, sitting at the end of the method declaration, tells Visual Basic 2010 that this method will return a double precision floating point number back to whomever calls it. So that means we're calculating the area, right? So we put in the radius and we get out the area. And it's saying that what we get out is also a double. It's not going to be an integer, it's not going to be string or whatever. It's going to be a double. So that's what this double means. This double means about the input is going to be a double, and this means the output is going to be a double. He says, so now you can look at the method properly. First, you know that to find the area of a circle, you have this algorithm. Get the number that represents the radius of a circle, square the number, multiply it by pi. And that's exactly what you've done. He says here, the math.pi in the previous code is a constant defined in .NET that defines the value of pi for us. The last line, you need to, after the last line, you need to return the result to whatever code called the method. This is done with the following statement: return the result, comment, and then return double result. So this defines what the output of the function is going to be. So remember that this equaled the area, so we're outputting the area. Okay, now going back to the button one-click method, so what did we do? We first defined a variable called double as area. Double area as double. We need that because we want to accept the output from our function. So we want to accept the output from our function and put it in a variable. Since this is outputting a double, this should also be a double. And then we're just going to take this and display it using the toString method. He reminds us that using parentheses at the end of a method name is how you send the parameters, right? So we had to use parentheses at the end of this method name. We use these parentheses, and then we can send the value of the parameter. He says in this case you're just passing one parameter, and you're passing the value 100. He says after you call the method, you wait for the method to finish calculating the area. The area is returned from the method. The return result line defined from here, like we said, and stored in a variable called double area. You can then display this on the screen in the usual way. Okay, a little bit more on this about choosing method names. How do we give the so here's the name we gave to our last example. The .NET framework has a few standards for how things should be named. These conventions help developers move between languages, a topic discussed in Chapter 2. We recommend that whenever you create a method, you use Pascal casing. This is a practice in which the first letter of each word in the method is uppercase. So capital C, capital A, capital F, and capital R, called Pascal casing. But nothing else is capitalized, only those first letters. This is merely a suggestion for best coding practices, and it is not a requirement of Visual Basic 2010. So here we have two other examples. Note that even when an abbreviation is used, in this case XML, it isn't written in uppercase. So he means here. They didn't write it in uppercase. This alleviates confusion for developers who may not know how something should be capitalized. Next, he says, we recommend that you always write parameter names in camel casing. If you've ever seen Java code, you'd be familiar with this. So in Java, they use this kind of style. To get camel casing, you do the same thing as Pascal casing, but you don't capitalize the very first letter. So here, this is called camel casing. So or here, this is called camel casing. So this is capitalized, and the R is capitalized, the D is capitalized, but the first letter is not capitalized. So that's called camel casing. So they suggest that for parameter names, you should use camel casing. So it helps you to distinguish between what's a function or a method and what's a parameter. Again, abbreviations such as DNS here are not treated as a special case, so they appear as a mix of upper and lowercase letters, just as in Pascal casing. Camel casing, the name comes from the fact that it has a hump. In Chapter 2 you saw that .NET isn't tied to a particular language. Because some languages are case sensitive and others are not, it's important that you define standards to make life easier for programmers who may be coming from different programming languages. The term case sensitive means that the positions of uppercase and lowercase letters are important. In a case-sensitive language, my account is not the same as my account. However, Visual Basic 2010 is not a case-sensitive language, meaning that for all intents and purposes, you can do whatever you like with respect you can do whatever you like with respect to capitalization. In other words, my account would be the same as this. Okay? And then he has a note. Note that languages such as Java, C#, and C++ are case sensitive. Okay, we have one more very important topic, but I'll stop this video and make a very short video on this topic as well.